Today we're starting 4.2, page 205, which is Triangle Congruence by SSS and SAS. Okay, SSS is side, side, side. So obviously, if you have two triangles and that side corresponding to that side is the same length, likewise, these two corresponding sides are the same, and those two corresponding sides are the same. Obviously, the triangles are exactly the same size, which implies that their angles are exactly the same measure. So if you have side, side, side congruence, that is a way that you can prove that two triangles are congruent to one another, because all three sides in one triangle are congruent to all three sides in another triangle. And that leads us to postulate 4.1 at the bottom of the page. If three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. So if we have this triangle as ABC and this one as DEF, we need to be able to write a triangle congruence statement that says triangle ABC is congruent to triangle DEF. Notice A and D are in corresponding places. Those angles are in the same place within their respective triangles. B and E likewise, and C and F likewise. Okay, so SSS is the first triangle congruence postulate that we learn because it makes the most sense. It's the easiest one to recognize. Okay, so on example, in example 1, page 206, we are going to do a proof. Okay, we're jumping to the quick check. So what you will do when you are writing a triangle proof or any proof going forward is to draw the figure, because when you draw the figure, that is going to help you as you mark the figure with your information. That is going to help you determine how these triangles are congruent to one another. Keeping in mind, SSS is not the only triangle congruence theorem that we've got. There are 4 of them. So if you draw these triangles and you mark them according to the information that you're given, you'll be able to see what triangle congruence theorem or postulate you're using, and then you can say the triangles are congruent by SSS, SAS, etc. Okay? So we draw the figure, we write the given, and then underneath that, we write what it is we are proving. That triangle FGH is congruent to triangle JKH. Okay, so we're going to write statements, and as we go through writing the given, then that's when we're going to go back and mark our illustration with the information, so we can follow exactly what that given is and put it onto the figure. Okay, so statement, the first given, HF is congruent to HJ. So let's mark that. Okay, I'm going to change colors real quick. So HF right here is congruent to HJ right there. Okay, the next part that we're given is that FG is congruent to JK. Now let's mark that. FG is right here. JK is right there. Okay, notice I used one tick mark on FH and JH and 2 tick marks on FG and JK, because FG is the same length as JK, but we don't know that it's the same length as FH or not. So we have to mark it with a different number of tick marks in order to avoid the confusion of, well, those are the same length. You don't know they are. You never assume anything. Therefore, we're marking them different. The next thing that we're told is H is the midpoint. Okay, so I am abbreviating a little bit. H is the midpoint of segment GK. Now here is where we have to use what we know about midpoints to mark the figure, okay? So if we know that H is the midpoint, right there, H is the midpoint of GK. The midpoint implies that it's cutting something in half. That's middle, okay? So if H is the midpoint of all the length GK, that means that GH is the same length as HK. All right, that is the implication of H being the midpoint. Okay, so I'm going to backspace that away just for a minute here so we can finish up that first statement by saying that's the given. Okay, now statement 2, going back off of the statement previous. This is how proofs work, so to speak. You look back at what you just wrote, and anything that affects your next statement leads naturally into the next statement. For example, we know that HF is congruent to HJ. We mark it on the figure. There's nothing that we can imply or assume from that. That's just fact. Likewise with FG being congruent to JK. There's nothing you need to imply. There's nothing you need to worry about. It is fact. You can't go any further with that. H is the midpoint of GK. That is something that we can build on. So going from that part of the statement previous, statement number 2 is going to be that GH is congruent to KH. So GH is congruent to KH. And the reason that phenomenon exists is because of the definition of the midpoint. Because H is the midpoint, that's why GH and HK or KH are congruent. Now, if you look at what we've got all 3 sides marked in one triangle being congruent to the corresponding other 3 sides in the other triangle. So we are ready to make our statement. It is that simple thus far. Using the given, or using what we are to prove, we're going to use that triangle congruence statement. Triangle FGH is congruent to triangle JKH. You know what, I'm going to erase some of this. My left-handedness sometimes gets a little bit in my way. Okay, so triangle FGH is congruent to triangle JKH by SSS. And it is that simple. Once all 3 sides corresponding are congruent to the other 3 sides in the other triangle, your work is done. Okay, that is a 3-step proof. Very, very basic. Okay, the side is the easiest triangle congruence statement or theorem that you'll use. All right, now the next one on page 206 as well, postulate 4.2, we have side angle side. Now this is where it gets a little bit tricky. Side angle side. So the S stands for side, and the A stands for angle. So you notice even when you look at this SAS written out, the A angle is between the two sides. So when we use the SAS postulate for proving two triangles congruent, our sides will be next to each other, and no matter what sides we mark, two sides are always going to be next to each other. What's important is the placement of the angle. The angle is between the two sides when you write SAS. Therefore, the angle has to be between the two sides when you mark your triangle. For example, this triangle on the right is congruent to the triangle on the left. Corresponding sides are congruent, and the angle in between those two sides is marked as congruent. What I'm going to show you is an SAS that is not an actual SAS, okay? So we've got this triangle over here, and we've got this triangle over here. I'm going to mark that side. I'm going to mark that side. That side. So those sides are congruent, okay? So those are the S's of SAS. This angle here I'm going to mark, and that angle there I am going to mark. As you can see, over here on the left, the angle is between the two sides, as it should be. The triangle on the right, the angle is not between the two sides. It should be right there, and it's not. Okay, another instance of where SAS is not actually SAS is if you've got your two sides marked here and your angle is over there. Again, that angle needs to be between the two sides in order for SAS to be true. So the placement of the angle, be very, very careful of that. Okay, so what we're going to do is example 2 on page 207. And we're going to jump right to the quick check, and I'm going to draw that out as best as I can so we can look to see what other information do we need to be able to say, and that is not, of course, to scale at all, but we'll do our best here. As long as I mark it, I can say this is congruent to this as long as I mark it, because you never assume by looks. If I mark it, it's true. Okay, so we are given AB is 7, AC is 6, AD is 8, and DC is 7. So if we want to, it says, what other information do you need to prove angle or triangle ABC is congruent to triangle CDA by side, angle, side? All right, so when we're looking here, I'm going to change my color just to make a point, okay? This is a shared side, okay? That side in both triangles is congruent, okay? Now, we have 7 over here, and we have 7 over here, okay? So far, that side and AC and this side and AC are congruent, right? Those are congruent to each other. Let's mark that, okay? 7 and 7, those are congruent to each other. And AC is congruent to itself. So if we're looking at SAS, we have to have the angle nestled in between the two sides of each respective triangle, meaning this angle right here, which is SAS nestled in between AC and DC, would have to be congruent to this angle up here, okay? So AB and AC are the two sides. Therefore, this angle is the angle in between. Likewise, AC and DC are the sides in the other triangle. Therefore, that angle right there at angle C has to be the angle in between the two sides. So that information that we would need to know, writing it out, the information that we would need to know is that angle DCA, this angle right here, has to be congruent to angle BAC, which is this angle right here. That would be the information that we would need to know to say that triangle ABC, this one right here, is congruent to triangle CDA, the one on the left. Okay? Now you can say that those triangles are congruent to each other by SAS. Okay, now we're going to use both of these, SSS and SAS, in example 3 to say, are the triangles in fact congruent? So we're going to jump to quick check 3 at the bottom, and I am going to draw out as best as I can the shape that we are given, A, E, B. Let me just make something clear. The only time that you guys will ever need to draw out your illustration is when you're doing a proof, okay? If this was just a homework problem that did not need a proof, you wouldn't need to worry about drawing out this figure, okay? But I'm drawing it so we can mark up the figure to determine how we can find these two triangles congruent to each other by either SSS, SAS, or maybe nothing, okay? Because in quick check 3, it says, from the information given, can you prove that triangle AEB, which is the one on the left right here, is congruent to triangle DBC? Okay, we are given that EB is congruent to CB, and those have been marked with 2 little tick marks, and AE is congruent to DB, okay? Well, if we look here, the corresponding sides, EB and CB, those are the same, okay? Those are corresponding. And if we flip the triangles, let's draw these so they are facing the same way, okay? So E, A, B, we've got a tick mark and a tick mark. What we're going to do is turn this triangle so D is up top, okay? So if we turn that triangle, D here, so D, C, B. So DB is right there, and BC is right here. So what we can see is that those sides are corresponding to one another, okay? So far we've got SS. Unfortunately, SS is not a triangle congruence theorem. We'll get to that when we deal with similarity, but as far as triangle congruence, SS ain't gonna cut it. Okay, so if we look and we want to prove these triangles congruent by what we are given, the only bit of information that we can bring to the table, so to speak, would be to say that these two angles right here are congruent to each other by vertical angles. So in the triangle on the left, that is angle ABE right here, angle ABE. The triangle on the right, that would be angle DBC. So DBC is right here. Okay? Well, it looks like Over on the right, we've got SAS, we've got the side, the angle, and the side, but the triangle on the left, our angle is misplaced. See, when you separate those triangles and you mark them accordingly, it's really easy to see that those triangles are not congruent by anything. In order for that to be SAS, angle E would have to be congruent to angle B, and that is not the case. So you cannot prove that those triangles are congruent because neither one of the postulates apply. Okay, it's very important that you understand, again, the placement of that angle. Okay, this concludes Triangle Congruence by SSS and SAS, and you will be assigned the appropriate IXL that goes along with this. All right, guys, you're doing great. Keep it up. Thanks.